Let's talk about hubs. Hubs are optional. They're not required to use your BroodMinders, but they're super handy because they will automatically get data to my BroodMinder. You won't have to go out and harvest it. We've got several different kinds, and I'll talk about the different kinds we have, and then go through a fairly involved video here about how all these work and all of that. We'll divide the video into chapters to make it easy to jump around to where you want, but we'll put it all in one place so that you can find it easily. The hubs we make, our favorite is the T91. So it's going to listen to the Bluetooth signals that the sensors put out, and then it's going to listen for that, and once an hour send the data up to mybroodminder.com. So it is by far the simplest. If you have cell coverage, we really recommend it because it also contains a temperature, humidity, and barometric pressure sensor. And we include it with a solar shield so that you essentially have a little weather station. So that's our favorite. We also have, a Wi-Fi hub. The Wi-Fi hub works well. It can be a little tricky because different Wi-Fi networks are different. Some schools have them locked down or whatever. So we don't recommend it as much, but if you don't have cellular coverage, it is also a really good alternative. It does the same thing operationally. It listens every 10 minutes to the sensors, and once an hour it will send it up to the network. Another option we have is what we call a SubHub. If you are very remote and don't have any cellular or Wi-Fi or anything, the SubHub will do the same thing, except it just stores its data right within itself. So a good use case was Etienne Tardif in the Yukon. He didn't have anything, so he loved the SubHub because it would listen to all 30 or 40 of his sensors, store the data here. Then when you go to read the data with your phone, it's only reading one device, and it's super fast compared to scanning all of the devices individually. So it's a nice option if that's what you have. Then the last hub we make is more as a specialty one. It's LoRa. So LoRa stands for long range. It's a standard that's used by a lot of people. The LoRa Hub is solar powered, and you also need a LoRa gateway. So people who know about this stuff, we support that. If you need it, we'll do that special for you because it's a little bit unusual. We've used them in some difficult places like in a mountain valley where you don't have cellular, but it's at the top of the mountain. You can put the gateway up there and put the LoRa hubs down in the valley. So we have that, but it's a special case. Going back to the T91, when we ship it as a weather station. So you'll get this solar shield that we buy from La Crosse, and it works very nicely. Comes with a little clip so that you can fasten it to a fence post or a tree or something. Ideally, you will put it in a shady spot because the sun beating on it, it still it gets more accurate, but it will be the most accurate if it's in the shade. We also include this black bag. This black bag is actually very important for two reasons. One is that it keeps critters out. I ran mine a couple of years, and earwigs love to get in. It's a tiny bit warmer in here, and it gets sort of disgusting. So putting it in the bag, you can keep the earwigs and ants and like that out. But more importantly, when Nordic designed it, one of the chips on it, this little guy right here, is sensitive to infrared. And you know what? The sun puts out a lot of infrared. Took us a while to find that, but once we did, the black bag protects it from infrared. And so it's really important that when you get it, the black bag is not just a shipping container. It's very important. Another little accessory that we sell is a magnetic mount. It just can screw onto the bottom of this, and if you have a metal lid on your hive, you can hook it on like that. Again, it's better if it's in the shade, but sometimes this is sort of cool. The battery in the T91 will last about 6 months. It depends on if you have any SubHubs running too, but in a standard setup, it will last about 6 months, and you need to recharge it. You can take it in, and it has a micro USB connector on it here, and you can charge it a few hours every 6 months. Alternatively, go to Amazon. You can buy it from us, but just go to Amazon, and these little lipstick batteries that are 5,000 milliamp hours, and we'll put a link for that, will fit inside here, and then you can put the charging cable and this, and you can leave it overnight. It'll have 2 or 3 or 4 or 5 hours to charge. Then you can take the battery back, charge it up. If you got more than one, you can carry it around to the different sensors. And that's a pretty, these batteries are not very expensive, but you're really best just buying it yourself, because you get it fresh, and we don't have to mess with it. The last option for the T91, we really like this solar device from Voltaic. We've used Voltaic for a lot of years. They're in Brooklyn, New York. And they have now built a little unit which has the battery and everything built into this. We tried a lot of different inexpensive solar panels and solar battery combos. None of them worked. Every time the light gets dim, the voltage out of the connector would go down and reset the T91. This works perfectly. Right now, it was $99. I think they're coming out with a new version. It'll be $125. Well worth the money. You can just mount it. You also need to purchase this adapter, and this adapter is the micro USB. So you have mini USBs, you have USB-Cs. This is the micro USB, and we'll put the model number. But it plugs in just like that, and it plugs into their list. And what you can do with it then is you can plug it in, you can put it in the bag with the connector sticking out, tighten it up, and then it will go into the bag, and you can either put a little notch in the housing here, or it can go on sort of like this. I think I would put a notch in it, and then, because without a notch it goes on a little bit crooked, but then you have it solar powered, and it will last for months and months and months. So that's a really nice way to do it. So that's all. Oh, and the last accessory. So if you do have, let's get that out of the way. Okay, if you do have marginal cell, we still sort of recommend this, and we'll work with you to get it right. And if it doesn't get coverage, then we can look at other options. But if it's marginal, then we do have a antenna kit that you can add. And the way that works, just show you briefly, the antenna screws onto the base plate like this. And the T91, they used a crazy connector for the antenna. And so this cable we buy is actually $70 or $80. It's sort of it is expensive, and it wants to pop out. So we designed a little clip here that you can see that holds it in place. We put a screw into it, and then you plug this in with a tie wrap, and it holds it really securely so that it doesn't fall out. Then once you have all that, and I'll show that in more detail later, but then it goes back in the black bag. Always use the black bag. It's a little bit tight because of that. And then it can sit in here. I'll be a little bit careful with the cable. And then, so we've had good luck with these antennas. It gives quite a bit more range. And like I said, the hubs are the most complicated part that we do. There's a couple of things that make it complicated. One is the cell system is sort of changing all the time. They obsolete things and bring in new utilities. The software to do this is a lot more complicated. We want the long battery life, but it takes more power to do that. So it's our most complicated components, but it also is the most useful. And once you have that data coming in, you know, whether you're sitting in Europe or United States or anywhere in the world, you can get on the internet and see your live data. And that's really nice, especially during the spring. I'll just say Theo and I were at EAS one year, and I sat there while I watched every afternoon about 2 o'clock my bees getting attacked and getting robbed out. I could have sent someone to do something about it, but I just sat there and watched it. Anyway, it does show you when the honey flows are. If your hives are remote, a couple of hours away, people use it so that they can see if they need to go in and super up, or if the honey flows over and they need to pull the honey before the bees consume it all. So there's lots of things you can do. The hubs are super useful. They're a little bit more complicated. Next, we'll get into what you can see with your phone and the BeesApp, and then we'll go into my BroodMinder and show that. So stay tuned. Okay, so now let's talk about installing these devices and what you have to do to get them up and going. Again, we'll start with the T91, then go through the other ones. They're all very similar, but the T91, since it's our favorite, it gets to go first. So what you'll see on the end is a power switch, the charging port. This is a programming port that we use here, and then it's got a button here in the middle. So all you got to do to get it going, the SIM card that we include sits right here. All you got to do to get it going is take the power switch, and it says off and on, so we turn it on. And you'll see a series of flashes. So during this blue flash, we can do firmware updates. The double green flash was it is found a cell tower. Now the next flash is it found Amazon web services that we use, and now it's going to look for any devices it can find. Now we've only got one device running here, which you can see, whoops. You can see on the app, and you see the 540215 is this hub, and so it shows up just like all our other devices in the BeesApp, and there's a lot of information we can get from this, so we'll take a look at that in the middle. But basically, if during operation, it might take might take 2 minutes to find your cell towers initially. Some are more remote and harder to get to than others. But if you see green flashes, everything's going okay. If you see red flashes, something didn't go right, and we got to troubleshoot it. But and like I said, the blue flash is only for firmware updates when we do that. So every time it reboots, and we can turn it off, and we can turn it on again, The sequence you'll see is green, blue for 5 seconds. That'll go off, and then that green flash was it found the cell tower, and then that flash means that it found Amazon and my BroodMinder, and then the last flash was it found the T2 that I have running. If you have a lot of devices, you'll see a lot of flashes as it finds all of that data. Then it stores that data for up to an hour, or if it can't get through, it'll store a little bit longer. But then once an hour, it will send that data to my BroodMinder. If you have a swarm or something like that, it sends it immediately, so you'll see that every 10 minutes, because this is going to wake up every 10 minutes, look for all the BroodMinders it can find, store that. If it's it's time to upload, it'll upload it. If it finds that a swarm is going on, it will upload it. Or if you push this button right here, it'll do an immediate upload and transfer. So that is handy when you're trying to troubleshoot or get everything set up right. So let's look at the app. And with the app, then we can claim the device. So let's go ahead and claim this one. Yes, claim it. Then it'll show up in your My BroodMinder list on the PC app. It's claimed successfully. And then we can look at details, show details. And it gives you a lot of information about this. This was really complicated to get working because we're installing them in Europe, South America, the US, Canada. Everybody has slightly different networks and trying to get it all going. So we ended up doing a major firmware update last fall and just now have a lot of information. So just going through here quickly, the firmware this is running is version 346. The last time it uploaded was just a few minutes ago. The battery internal to this is 99%. The temperature, 80 degrees here. And the Bluetooth signal, you can see I'm pretty close, is 100%. Now, the RSRP, RSRQ, and SNR are 3 different measurements that tell us how good the cell signal is. I don't have great cell signal here, so you can see poor, good, okay. And we sort of have to take all 3 numbers to figure out, if there's a problem or that. But if you're in a good location, it'll say good, 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 and that's your golden then. The band and the ACT and the MNC tell us more about the exact cell tower that it's connecting to and what carrier it is. 410 happens to be AT&T. Elapsed is how many cycles it has run. So as time goes on, that number will just keep climbing. Minutes until upload. So in 18 minutes, it's going to upload. It uploaded just 1 minute ago, and it sent 1 sample because that's all I have. So in the black box then, it's the T91, all our devices are constantly sending out little advertising pulses from the Bluetooth to tell you how things are going. And so when nothing's happening, we have it going tick tock every, I think, 2 minutes or every 5 minutes. So you can see it says status 10. Status 10 is a tick. I think status 11 is a tock. So now let's watch as I push the button and see what happens. So start BLE scan, Bluetooth low energy scan. So it's looking for that. That's status 21. It's just the message number 21 is start Bluetooth scan. So it'll do that for, I believe it's 10 seconds. I forget the exact timing that we set up on all these. Okay, connecting to cell. And so once it connects, it reads the T91 sensors. That's the temperature, humidity, and barometric pressure sensors. AWS is Amazon Web Services, so it got it there complete. And now it goes back to TikTok. So there's a couple other, if the phone was faster, it would have caught a couple of more things. But what you see may be slightly different, but the important message is AWS complete. And then now it goes back to TikTok. And you can see that elapsed 3 minutes until upload, still 16 because it's going to do it at, let's see, 10 after 8, it looks like. And that's how you do that. We also have some more debug stuff that we will guide you through if we need more information. You can reboot it here. You can actually tell it to upload now, same as pushing the button. So if it's in there and you just want data right now, you can hit upload now. And you can also view the log, which is telling us the exact process that the modem went through. So when things don't go right, it gets really complicated because you have Bluetooth to here, you have here to cell, you have cell to Amazon, you have Amazon to my BroodMinder. So all these links we have to be able to look at and see where things went wrong if they do. But we have a lot of tools that Amanda has developed over the years, and we've gotten pretty good at figuring that out. So that's T91. Now let's talk about, so we'll just let that keep going, Wi-Fi. So Wi-Fi is very similar. Open it up. It's got a couple of little standoffs here. You can see this is the Wi-Fi transmitter. This is the Bluetooth. We use similar board to what we use in the W3 and the scales and all that. But it's running completely different firmware because it has to talk to Wi-Fi, right? So it goes in to start it up. You remove the tabs. Okay. And now we should see it show up in our little thing here. There it is, 600400. It belongs to a different account because it belongs to my personal account. But you can still see the details. And it's going to show you very similar information to what the other one did. You can configure the Wi-Fi. So because we have to connect to our local Wi-Fi network, what we do is scan for devices or scan for networks. So it's scanning for networks, and hopefully it finds some here. It found Bees on main 2G. So, and I know the password for that. This is Bees, setting credentials. So this is a lot more complicated than just turning the power switch on. But if all you have is Wi-Fi, then okay, this will work. Network set successfully. Okay, so it connected okay. We can go back here and say upload now. And it shows down here, device attempting upload. And let's see how it does. Device is seen. We can also view the debug log and copy it if we need it. Let's see here. Configure. Upload now. Device attempting up. Oh, it did. Okay, I didn't have to do that. It just takes a few. It also scans for a while. We don't have as many debug messages because this is not as complicated linking everything through. But once it's done, you can see devices seen 1. Upload attempts 7, upload success is 7 since I hit it a couple of times there, and when it first turned on, upload failures 0. So this is talking from Bluetooth to here to your Wi-Fi network to mybroodminder.com, and so all those links have to be done. And so here we go. that's about it for the Wi-Fi hub. The things you might run into is just the sensitivity of your Wi-Fi. It's always nice to start working with these devices like at your kitchen table or something like that, where you have a really nice strong Wi-Fi signal or you have a nice strong cell signal, because as you're making sure everything's working right, it's just a lot more conducive to do it at the kitchen table rather than when you're out in the apiary and you're not sure how strong your Wi-Fi signal is out there. When I put it into mine, I had to get a repeater, which you can get on Amazon, and to extend the Wi-Fi network out there. It's a lot more complicated. There again, we actually priced this cheaper because we want people to use it. Costs us a little bit more, but we really want people to use the T91. Okay, so now let's talk about the SubHub. Why would you want a SubHub? You would want a SubHub if you have a lot of devices and you're tired of reading them all one by one, because each one can take a minute or so to read. So if you've got a dozen devices, then it's going to take you 12 to 15 minutes to read all those. Now, you do it automatically. It's not a big deal, but the phone has to sit there and has to go through all this. If you have a SubHub, everything gets stored here, and it'll store thousands and thousands of records inside here. And then you can read all of those at once. To read, I think, 6 months worth of data on 20 devices was something like 2 minutes. So it's much, much faster to do it. Another reason you might want it is as a backup. So if you have really important data, we keep the data several different places. So the devices will keep the data for most of them up to a year. And you can read it, and there are ways that you can read the old data if you're missing some and want to get it. If you have the T91 running and it's going fine, but then you forgot to charge it and it doesn't do it, and you want that data, if you have a SubHub in the apiary, you can go and read that, and then through the magic of Amanda software, we splice that together. If there's a slight time difference, we might have to do a little bit of filtering on it, but we can put all that data, overlay, and then you don't lose it. Mission critical, if you're doing a research study or something like that, this is nice for that reason. Or if you have no connectivity out in your apiary and just want to read devices faster, this works well for it. So it's the same sort of thing. We put a couple of batteries in it. You pull the tabs, and then we'll see it show up. Show up here, 520400 SubHub. It looks like it probably needs a firmware update. Firmware update available. I'm not going to do that because, well, let's do it. Let's go ahead and update it. We don't need the readings. So when you do a firmware update, all our devices look very similar. It goes out, it connects it, it puts it into this OTA mode, over the air mode, where it can update the firmware. And why we update firmware, at this point everything is very solid and stable, but sometimes we want to add new features. Like we did to the T2, we added the feature that when it's in battery saver mode, it turns off and that. And I'll just mention that while this is happening. So once you have a hub, then you can put it into battery saver mode, because these will look every 10 minutes and they'll scan for device information every 10 minutes. So your devices, your temperature sensors and scales, they don't need to be sending out their data all hour. They only need to do it for about once every 10 minutes. Well, they do it for 10 minutes once an hour. And then the hub picks it up, it has that data, then the devices can go quiet and not use that energy to put out those advertising pulses. Okay, so complete update progress, 94%, 96, And so now it's updated, disconnected, and we can go back to here, and the little exclamation mark disappeared. Okay, and we can claim the device. And once again, when you claim a device, it puts it in your tree on the side of my BroodMinder. We can assign it to, let's assign it to a hive. We've only got one hive, bees on main, hive 01. Position, we're going to say this is outside. Let's see here. Outside hive, done. And start it right now. Okay, so now it will show up in our device list, and you'll be able to look at the data with mybroodminder.com. And if we look at the SubHub, it has sort of a cool feature. Come on. So show details. And we can show all devices. So with it in this mode, it will look for all of the devices out there advertising. So you can see 47428E, it's the one in my hive right here to my left, and it's showing you everything that it can find right now live. So that's sort of cool. If we had 20 devices and you weren't sure if you were close enough to all 20 of them, you could go to here and see that. Sync all devices, it reads all the data and pushes it up to my BroodMinder. If you are very remote, you can sync all devices, it will read it to your phone, and when you get to someplace that you do have internet or cell connection or whatever, then open up the BeesApp and it will take all that data that it has stored in the BeesApp and push it to my BroodMinder. So getting data from here to there has been a real challenge, but we've got a ton of cool devices in place and a ton of cool features that let this all work really nicely. So with that said, I think we can move it around, we can delete it, we can sync, do all the normal sorts of things. So I think that is pretty good about installation of these devices. Like I said, the LoRa is a special case. It works well, but it's more complicated. So if you need it, we'll work with you directly on that. And otherwise, we'll move on to talking about some of the technical background on these sorts of devices and some of the problems that we've solved. Some of the information that's interesting to some of us, but not all of you. Now I want to talk about the history of what we went through. This is unimportant information, but maybe some people will enjoy hearing the struggles we had. We started pretty much as soon as we got the BroodMinder Ts delivering. People said, I want to look at them remotely. So Mike had a friend named Amanda, and she came and worked on the firmware for the first version, and she's turned out to be the best programmer I've ever worked with. But it was based on this, BLE 121, which is a more sensitive and more powerful Bluetooth chip than was in the Ts. So we used it, and it used the same BG script that we used in the BroodMinder T devices. So very limited, really tricky to work with. Amanda had never done something like that, but she made it work and really showed us that she was as flexible and as good as she is. So the board was based on that chip. Then we bought these little click boards because there's a lot of variety in them, and we could get a 3G for Europe and a 3G for North America, and we could get the Wi-Fi chips too, so all use the same platform. It took a lot more power, so then we found Voltaic, which had these batteries which have the special ability to be in an always-on mode. Most batteries like this, once they get done charging, they go into a deep sleep. so that they don't wear out, and they stay like that until you plug and unplug them. Voltaic made a special version. We've used a lot of them over the years. They updated the version, and it's even better now. And now they even have, this version, which is we're going to use going forward. Economical and really well done. So this then went into our hub, and pretty expensive. The circuit board and everything, there's a cost to that, but by the time you add a box, a solar panel, the aluminum parts to hook it together, and the battery, the price went up quite a bit. We've never charged as much markup for the hubs because they're enabling all our other devices. So that was how we started out with it. They worked very reliably. They kept chugging along until AT&T and Sprint and everybody in North America obsoleted 3G cell phone system. So that forced our hand. We had played around a couple of times with the T91 by Nordic. This was their first cell phone chip that they'd done. They'd done a lot of Bluetooth chips, and I tried a couple of times to make it work and failed. But then with the sunsetting of the 3G, we were really pushed to make this work. So put a lot of months into the work. I'm not a great programmer, but struggled along, got it working, not reliably, but we could put in a watchdog timer so that if it didn't work for 8 hours, it would reboot. Not the way we want to do it, but it was new for us, but it's also new for Nordic. It uses a real-time operating system. It's quite complicated. I can't remember which one it uses, but it's quite complicated. A lot going on. Hundreds of files that they customize for their use, and there were quite a few bugs. Various things in their modem software, which is don't have access to, their operating system software, and the driver for going to the Bluetooth chip. So it's a huge learning process. We really like the device, though, for a couple of reasons. One is it's globally certified. That's a huge cost for when you get onto a cell phone network. You have to do the radio frequency testing to prove that it's in safe levels, but you also have to certify with the cell phone companies. And when you're talking globally, especially, then you're talking about France and North America, Germany, Korea, Australia, all those, and it ends up being tens of thousands of dollars that, frankly, we don't have. So we're really motivated. It also has the temperature and humidity and LEDs and pressure sensor and some other stuff too. It's a really nice development kit, and it's pretty cheap for all that purpose. So we struggled for a long time with it, then brought a consultant on, an expensive consultant, in Connecticut, and Jared really knew his stuff. He got us a lot farther. Still, it was not 100% reliable, though. And last fall, I went at it again for about 3 months. We tried this utility called MemFault, which is supposed to help you find things, except that it's so big that we had to shrink the code. It created other problems. Spent a month with that and threw it away because it just was creating more problems than it solved. And I'll take ownership of some of those problems. I'll take ownership of some of those problems because I'm just not a high-level programmer. But we struggled through it, added a lot of diagnostics, and now we get a lot more cell phone information, what tower it's going to, what the different levels are, all that. We also have coming through Bluetooth now, which is really useful. If you can't get to the cell system, then how do you see the data, right? So it's been a huge struggle. We've put a ton of effort into it. Now, finally happy that that is working very reliably. And yet there's still some, demons out there that we're trying to find. Hologram, they have their own problems. So the latest problems we're having were actually hologram problems and not us. We've switched to a company called Once out of Germany for our SIM cards. They seem really good. How long will that be good? We'll see. So it's a constant struggle of trying to make all this work, hang together. It's a bunch of links along the way. We were using Google for our one of the links, and they shut down their IoT group, so we had to switch to Amazon. So not complaining, but just letting everybody know that it's been a real struggle to make this stuff work. We evolved the Wi-Fi to this board to try to make it a little bit more economical for people and take a bit more control. It's actually our XLR board, which we use in our scales, and then with a Wi-Fi module that we found. So lots of little things, lots of software that hooks this together, lots of software on both the web side and the local side and the device side. So there you have it. That's enough complaining, and I hope you enjoy them. We certainly put the effort into it. And remember, every hive counts.